Hi everyone, thank you for your interest. In this video, we will briefly present you our work on online active model selection for pre-trained classifiers. In this work, we seek a solution to a common question in ML practitioners' mind. For any target classification task, how to select the best ML model. To understand the need for an answer to this, let's have a look at some time series data. Due to heavy data drift, a single model trained on a specific distribution would not perform well when applied later. You may say this is simply a domain adaptation problem, but there's probably no single approach that can cover all circumstances. On the other hand, given a stream of freshly collected unlabeled instances, the natural way to select the best pre-trained model is computing the test accuracies, which requires a great labeling effort. To tackle this, we propose Model Picker, an algorithm that is capable of picking the best pre-trained model on your freshly collected data, only with a little labeling effort.
Our setup is as follows. We have a set of pre-trained models and a stream of data that is arriving one sample at a time. At each round, we observe the predictions of the models on that sample, and we decide if we query the true label for this sample or not. To keep track of the model's performance, we assign a weight to each model. These weights are carefully updated as we observe the true labels. We can guarantee the model with the highest weight tends to be the best model so far, and we can use the weights to select a model at random and output its predictions for the rounds we do not query. Our query decision is based on how much information we lose if we do not look at the true label. We compute the losses for different possible labels and take the largest variance with respect to the current weights among these losses as a measure of informativeness. We use this measure to tune the probability of querying the true label. Note that the disagreement of the predictions is automatically taken into account. For example, if all models predict the same label for the sample, it is useless to query the true label, and indeed, the probability of querying will be zero in this case. We provide several results for both adversarial and stochastic streams. We show that the performance of Model Picker is close to the performance of the best model in hindsight. We also prove that the number of labels we request is small and grows gracefully with respect to the stream size. It is shown that the probability that we misidentify the best model at any round decreases exponentially fast, as well as the gap between the accuracies of the return model and the best model gets very small by just a few rounds.
We conduct an extensive set of experiments using pre-trained models on common datasets and compare Model Picker to various selective sampling baselines. We observed that Model Picker requests labels for only a small portion of the entire stream to pick the best model. Moreover, this is significantly less than the best computing method. We also show that the regret of Model Picker is smaller in all cases, demonstrating the capability of Model Picker in model selection as well as sequential label prediction. To summarize, we introduce an online active model selection approach, provide extensive analysis on the theoretical guarantees as well as on practical performance. Thanks for listening, and we are excited to talk about our work in detail at poster session.